Hello everyone, this is Dr. Lennon, and I just want to look over a few of the examples from homework number 5 that might have been giving you trouble. So let's go ahead and let's jump in and look at number 3. So this question, it says, which of the following have x equals 2 in their domain? So when they say 2, they mean the number x equals 2. So let's just go ahead and look at the domain of each of these. So g of x minus 2 over x. We have division by x, so the only problem is that x cannot equal 0. So the domain here is just x not equal to 0, and that's it. So we can plug in 2. 2 is certainly in the domain there. For the second one is h of x, actually. So let's go ahead and look at that. H of x. We have the function the square root of x minus 4. So for this one, we would just need x minus 4 to be greater than 0, greater than or equal to 0. So x just has to be greater than or equal to 4. So x equals 2 is in the domain for g of x, but for h of x, it's not, because 2 is small. 2 is not bigger than 4, so 2 would not be in the domain of h of x. And for the last one, f of x, that's a polynomial, so the domain is all real numbers. So 2 is certainly in the domain there. So for number 3, you would just check the boxes. G of x and f of x, and h of x would not work. So for g of x, so h of x is this one. We should type undefined, I suppose. And for the other ones, we need to plug in 2. So this one would come out to negative 2, and this one would come out to 0. So let's go ahead and check that and see if we got it right. I'm not sure how we submit. I think we just go down to the bottom. Okay. So all the way down to the bottom. So if I submit, I thought there was a way where I could just look at the one problem at a time. But okay, so we got all the questions on number 3 right. So let's go ahead and look at... So I just wanted to make sure. I thought there was a way where maybe it's just on the right-hand side. I'm not sure. Okay, so let's go ahead and look at number 5, where we complete the table. So this is pretty straightforward. We're just plugging in numbers. So for number 5, we have the function f of x equals 6 times x minus 4, quantity squared. So really, we just need to be sure our order of operations are going well here. So we have some numbers, negative 1, 0, 1, 2, and 3. So for negative 1, we'd have to do 6 times negative 1 minus 4 squared. So that would come out to 6 times 5 squared, which is 25. So that would be 150. For 0, we'd get 6 times 0 minus 4 squared, which would be 6 times 16. Which would be 96. For 1, we would do 6 times 1 minus 4 squared, which would be 6 times 9, which is 54. 6 times 2 minus 4 squared is 6 times 4, which is 24. And 6 times 3 minus 4 squared is 6 times 1, which is just 6. So that's how you would compute number 5. Similar thing for number 6, you would just have to graph it. Again, drawing a bunch of graphs and matching them, you can use a program like Desmos, or you can graph them all by hand. So those graphing ones are pretty similar. Let's go ahead and look at 10, just for the heck of it. Let's go ahead and plug these in and graph them. So for f of x equals 6 plus the square root of x, again, we can make our table here where we have x and 6 plus the square root of x. And then for this one, this is going to give us our ordered pairs as well. let's say x comma y, which are just the first column and second column. So again, it makes sense to plug in numbers that have easy square roots, which is why they're choosing the inputs that they did. So we get 6 plus the square root of 0, which is 6. 6 plus the square root of 1, which is 7. 6 plus the square root of 4, which is 8. 6 plus the square root of 9, which is 9. 6 plus the square root of 16, which is 6 plus 4, which is 10. And 6 plus the square root of 25, which is 6 plus 5, which is 11. So we get all those values, and then if you wanted to, so our ordered pairs are 0, 6, 1, 7, 2, 8, 3, 9, 4, 10, and 5, 11. So if you want to make a graph, then our y values start at 6 and go up to 11. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 10 here, and this is 1, 2, 3, 4, 5. And then we go up to 1, 2, 3, 4, and 5. Actually, our inputs go much, much higher. So let's make more of them. So this would be 10 inputs, 11, 12, 13, 14, 15, 16. I'm just going to go up to 16. I'm not going to go all the way up to the 25. So we're at 0, 6, and then we're at 4, 6, which looks to be about right here. And then we are at, what am I talking about? We're at 1, 6. 1, 6. Whoops, I'm on eraser. So if we look at our ordered pairs, we're at 1, 6. Wait, what am I talking about? So I made some mistakes here. 0, 1, and then I was just counting. So yeah, these are mistakes here. Right, the inputs are the x values. So it should have been, for this one, 4, 8, 9, 9, 16, 10, and 25, 11. So we were at 1, 6 was the, so 0, 6, 1, 7. Now we need to do 4, 8. So 4 and 8 would be right here. And then we need to do 9 and 9. So 9 and 9 would be this point right about here. And then we have 16 and 10. So 16 and 10 is all the way over here. So we get the shape of our graph. And again, we know the domain of this graph is x greater than or equal to 0, so there should be nothing to the left of the y-axis. So anyway, that graph looks to me about like graph B here. Yeah, so it's the second graph. Okay, so why don't we look at an average rate of change problem. Let's look at 13. So number 13, let's say, so we have h of t is 2t squared minus t, and we have t equals 3 and t equals 6. So to find the net change and the average rate of change, we need to plug both of those values in. So h of 6 is going to be 2 times 6 squared minus 6, which is going to be 66. And h of 3 would be 2 times 3 squared minus 3, which is going to be 15, right? You're going to have 72 minus 6, which is 66, and 18 minus 3, which is 15. So our net change is just the difference of those two, 66 minus 15, which is 51. And then our average rate of change is using the slope formula. So the average rate of change is 66 minus 15 divided by 6 minus 3, which is 51 over 3, which I believe comes out to 17. So our average rate of change there is 17. Okay, number 14 and 15 are good things to know with our transformations. Let's just remember how those work. So a f of x plus 7 shifts f of x up 7 units. So that goes up 7 units. And b, if you're doing f of x plus 7, that changes your y-intercept from 0. Normally, if you had f of x, the y-intercept would be 0. So now to get a 0 inside the parentheses, you would need -7. -7 plus 7 would be f of 0. So your new y-intercept is at -7, so that would shift f left 7 units. So this shifts f of x left 7 units. And then number 15, if we have y equals minus f of x, this makes all of our y values negative, so this is, reflects about the x-axis. And then for b, y equals f of minus x. What is this doing? This is changing the inputs for your y values from, if your y value were at 3, now that same y value would be at -3. So that's reflecting about the y-axis. So this reflects about the y-axis. And you could pick a sample function and graph it, right? You could graph something like, y equals x cubed, and then look at y equals minus x cubed and look at the notation. So from that, for 15, we know if we're looking at the first one, it should shift it up 2 units. So for A, you should go up 2 units. So the answer here would be B, and so forth. So we have that transformation. Why don't we look at number 17, just to do one more example here. So g of x equals the square root of x minus 3. This should shift y equals the square root of x right 3 units. So if your regular square root of x graph looks like this, so if this is y equals the square root of x, then your g of x graph should go to the right 3 units. So it should go 1, 2, 3 to the right, and then start there. So this is g of x. So that tells you what your graph looks like for 17. It should look like the one that goes to the right 3 units, which, did I do it wrong? X minus 3. So it should go 3 units. Where's 3 units right? So we're looking for the red graph that is 3 units. Oh. We're doing it for each one. So for A, so this is part A of 17. For part A of 17, it would be 3 units to the right, so it would be this first graph here. So it would be this one. Why don't we do, let's do D, just for practice again. So you want to do the transformations in order. So D, let's say we have g of x equals minus square root of x plus 5. So basically what this does is it does 2 things. So this takes y equals the square root of x, and first it reflects about the x-axis. And then 2, it shifts up 5 units. So I would do that in 2 steps. I would say, okay, my normal square root graph looks like this. So I start, so this is y equals the square root of x. and then I would reflect it. So when you reflect it, you get this picture. And then you would want to go up 5 units. So you go 1, 2, 3, 4, 5, and then you get this picture. So this is our g of x equals minus square root of x plus 5. So on your graph, you would look for that picture, and you get the picture right there, the first choice again. Okay, so then we get to the last topic. We talk about combining functions. 19, pretty straightforward, just arithmetic operations. And then why don't we just go ahead and do let's go ahead and do 21 and 23 just for 2 more. So number 21, we have f of x equals 4x minus 2, and g of x is 5 minus x squared. So for a, we want to do f of g of minus 2. So this is f with g applied to minus 2. So g of minus 2 is going to be 5 minus negative 2 squared. So that's 5 minus 4. So we're just doing f of 1. And f of 1 is going to be 4 minus 2, so that should come out to 2. And for b, we want to do g of f of negative 2. Probably to illustrate that these are not the same. If you do them commutatively, typically they could be, but in general they will not be. So f of negative 2 is going to be negative 8 minus 2. So this is going to be g of minus 10. And then this would be 5 minus negative 10 squared, which would be 5 minus 100, which is negative 95. So why don't we go ahead and check that we did the math right there. 2 and minus 95. And I wish there were a way to just check right here. I guess we have to submit though. Submit and come back to 21. There we go, so we got it both right. Then let's go ahead and look at number 23, where we're doing the same thing, but we're just finding some formulas. So if we have f of x here is 3x minus 2, and g of x is 4 minus x squared. For a, we want to do f of x. So we actually want to compose f with itself. So that means we take the formula for f, and then this x that's being multiplied by 3, we just replace that x with the whole formula again. So this is 3x minus 2. And then if we want to simplify, we can distribute. So we get 9x minus 6 minus 2, and that finishes up with 9x minus 8. And then for b, they want to do g of x. So basically what we want to do again is write down the formula for x, so 4 minus, and then change x to parentheses, and we're squaring whatever's in the parentheses. Well, if we're composing g with g, that means we're plugging the whole formula in for g, the original formula, where that set of parentheses is. So in that parentheses, we're going to write 4 minus x squared again. And again, you could FOIL this out if you want. 4 minus x squared, this would give us 16 minus 8x squared plus x to the 4th. And then we would distribute that negative, so 4 minus 16 plus 8x squared minus x to the 4th. So this would give us minus 12 plus 8x squared minus x to the 4th. Again, to do this second line, I'm writing out 4 minus x squared times 4 minus x squared and foiling out that product. You can't go ahead and just try and distribute the exponent or something like that. So let's go ahead and make sure we got these correct. 9x minus 8 for the first one, and minus 12 plus 8x squared minus x to the 4th for the second one. So let's go ahead and Check that, and if we got that right, then we're all finished. Okay, so hopefully that helps with any problems you might have been having on this homework. So this is Dr. Lennon signing off.